Hey guys, it's me again. In this small video, I'd like to tell you about the ARP protocol. Imagine a small local network of a few devices, all connected to the same Wi-Fi router. Each of them has its own IP address, some routing rules, and other network stuff. Now, let's say Bob wants to send an HTTP request to Alice. From a developer's point of view, it looks pretty straightforward. It's just an IP address and port. But here's the thing. Computers don't actually send raw HTTP requests over the wire. What really happens is that first the HTTP request gets wrapped into TCP, then TCP gets wrapped into IP, and finally everything ends up in an Ethernet frame. That's the TCP/IP stack in action. Let's take a closer look at this frame. You will not find any IP addresses or ports at all. Instead, you'll see something completely different: source MAC address and destination MAC address. You can think of a MAC address as a unique ID for a device, and unlike IPs, they usually don't change. So, back to our example. Bob knows the IP address of Alice. It's great, but to send the Ethernet frame, he also needs Alice's MAC address, and Bob has no idea what it is. So, what now? This is exactly where ARP comes in. ARP is the protocol that computers use to figure out the MAC address for a given IP. And the way it works is super simple. Bob sends a message to the whole network, an ARP request, basically asking who has this IP. Alice looks at it, realizes, oh, that's me, and sends back an ARP response with her MAC address. Everyone else just ignores it. And that's it. Now Bob knows the address and can finally send the actual data. Let's try to program it. It's actually pretty simple. We are going to use a library called GoPacket and take a look at the ARP structure. We are interested in MAC addresses, so the address type should be Ethernet. And since we are using IPv4 to find the MAC address, the protocol should also be IPv4. The MAC address size is 6 bytes, the IP address size is 4 bytes, and the operation is ARP request. The source MAC address is our own address, so we already know it. The source IP is also known to us. The destination MAC address is unknown, but that's fine. We are sending this request to everyone, so we'll use a special broadcast address. The destination IP is also known. In my case, it's the IP of my second laptop. Next, we wrap this ARP request into an Ethernet frame using the same MAC addresses, and then send it. And now we can see that the ARP response we just received contains the MAC address of my second laptop. ARP has worked as expected. If you enjoyed this video, please like and subscribe. I'll publish the code on GitHub. Thanks for watching.